Now we're going to take a good hard look at the beautiful circle in the plane. And it turns out there are lots of different ways of thinking about and looking at the circle. And some of the structure that's inside a circle sometimes can be best seen by actually taking the circle and including some lines. So let's take some lines and some circles together and first begin just with some nomenclature, get down some vocabulary. So let's take a look. So here I've got a circle A. That means that it's a circle centered at A and drawn this way. So A is the center. And I've got all these lines. I've got a red line, a purple line, a green line, and a teal line. And the question is, well, there are all these different vocabulary words. There's the chord, the secant, the tangent, the diameter, and the radius. Now, some of these I think we're pretty familiar with. For example, the diameter and the radius. I think we're okay on those. But I want us to talk about what the other ones mean. So let's begin. First of all, let's start off with the easy ones. So let's start off with what a radius means. Well, we know what a radius means. It's just a line segment that goes from the boundary of the circle to the center. So do you see any radii here? Well, sure. AB is a radius. Are there any others? Sure, actually, there are a couple more. There's AE, that's a radius, and also AF, that's a radius. So let's write them down. What are the radii? We have AB, but we also have AE, that's half of actually a diameter. I guess I'm giving away the next one, and AF, but you knew that anyway. What about the diameter? Well, a diameter is a line segment that goes, that ends at one end of the boundary of the circle and begins at another point along the boundary of the circle and passes through the center of the circle. And so you can see here that while this here is a line segment that goes from one end of the circle to the other, it doesn't pass through the center. So it's not a diameter. This one is a line segment that goes to the center but doesn't go to the other side of the circle. But this one does both. Goes from one end of the circle to the other, passes through the center. That is a diameter, EF. So those are the familiar ones. But now let's introduce some really interesting ones that are really important, that are new to us, and will follow us along our math careers. First of all, let's just take a look at what a chord means. A chord basically is any line segment that cuts a circle at two places. So anytime you have a line segment that goes from one part of the circle to another part of the circle, you've got a chord. So what would be a chord here? Well, the line segment from C to D, just that segment, that's an example of a chord. Do you see another example of a chord? That's right. A diameter is actually a very special example, very special case of a chord. It does, in fact, touch the circle at 2 points. It happens to go through the center, but that's not even required anymore. So that's a chord. So that's a chord. What's a secant? Now, a secant is any line that cuts a circle in two places. So we need a line. Well, these are line segments, so they're out. This is a line, but notice that it just grazes the circle. It touches it at one point, so that's not actually considered a secant line. In fact, the only secant line is the line CD, not the line segment, but the line. And remember that I denote that with the little funny little arrows to mean the whole line chops in the circle at 2 points. And finally, the tangent, I guess by the process of elimination, you can guess what the tangent is. It must be the line M. But what does it mean? It means a line that just grazes the circle at one point. So it's a line that touches the circle at exactly one point, and if you think of the line cutting the plane into two pieces, the circle will definitely lie on one half of the piece and not the other. So this line has the circle lying on one side of it and touching it at one point. That's a tangent line. So M is the tangent line, is a tangent line. Anyway, here you get a sense of some of the vocabulary of the words that we're going to be talking a lot about. We want to get familiar with the chord, the secant, the tangent, and you already are familiar with the diameter and the radius. All right, let's take a look in the coordinate plane and actually see circles and lines all coming together. So here we see two circles and actually a blue line. We see a red circle that's centered at the point A. We see a green circle that's centered at the point B. and then we see this line, which is a blue line. And now I want us to identify a couple little pieces about this picture. First of all, I want to find the radius of the circle centered at A. So that's the red circle. Well, if its center is here, to find its radius, I want to know the distance from the center to any point on the circle. There are lots of different points I can pick, and I can use distance formula. But it's really easy just to realize that, in fact, I can go right from here just to the end right here and just count. 1, 2, 3, 4, 5, 6. So I see that this length is 6, and since the circle has constant radius, I know that the radius is 6. What about the radius for the circle B? That's the green circle. Well, its radius, we can count from the center out to the circle any way we want. Let's just count straight up to the left now. 1, 2, 3. And I see that this length is 3, and so therefore the radius is 3. What in fact is the coordinate of the point of tangency? Now, the point of tangency is the place where a tangent line grazes a circle. And you can see here that this red circle actually has a tangent line to it. That's the blue. The blue is tangent to the red circle A. And where's the point of tangency? Well, this is a visualization thing, so there's no way to know that exactly. But looking at the figure, it seems as though they touch right here. And what are the coordinates of that? Well, that looks like I've gone 1 over and 6 down. So that's 1 comma negative 6 for the point of tangency, at least given the interpretation of the picture. And what's the tangent line? Well, the tangent line is this blue line. What's the equation for that? Well, notice that the line appears to be horizontal, so it's going to be y equals a height of negative 6. And so the tangent line is y equals negative 6, and it's this line right here, this line right here. So you can get a sense of how circles and tangent lines sort of fit in when we're looking at a coordinate plane.